Hello and welcome to a new video on cryptography for everybody in the Basics of Cryptology series. Today's video's topic is hybrid encryption. Hybrid encryption is a combination of symmetric and asymmetric encryption. We structured this video into three different parts. In the first part, we will have a reminder what symmetric encryption is. After that, we will have a reminder what asymmetric encryption is. And finally, we will see what hybrid encryption is and how it can be built. After that, we will also have a look at how to build a hybrid encryption scheme in CrypTool 2. But before we start, we will have a look at this graph here, which you probably remember from all the videos of this series. Cryptography is the art of making ciphers, and cryptanalysis is the art of breaking ciphers. And in this video with hybrid encryption, we will have a look at cryptology, cryptography, modern cryptography, and of course, since we have hybrid encryption, we need symmetric and asymmetric cryptology. At first, let's recapitulate what are symmetric ciphers. And as you probably remember from the previous videos, symmetric ciphers use the same key K for encryption and decryption. We have a key K, we have a plaintext P, and we have a ciphertext C. And symmetric encryption works as depicted here. We give the plaintext to a modern symmetric ciphers, which is set to encryption mode. We provide a key and we get a ciphertext C. When we use the same key K and we provide the previously created ciphertext with the same algorithm but set to decryption, then we get our original plaintext. And clearly, to decrypt our ciphertext, we need the correct key K, so if we are not in possession of that key, we cannot decrypt the ciphertext C. There are some advantages and some disadvantages of symmetric encryption. The first advantage, of course, is it's very easy to use. You only need the key K, and then you can encrypt and decrypt, of course, using the key. And another advantage is that it is very fast compared to asymmetric ciphers. So for instance, with modern AES, you can really fast encrypt and decrypt plain and ciphertext. Some disadvantages of symmetric encryption algorithms are, at first, that the same key is used for encryption and decryption. This can be a disadvantage, because not only the receiver is able to decrypt a message, the sender is also able still to decrypt the message he created. Now think of Alice wants to send a message to Bob, and of course it has to be encrypted. So Alice encrypts the message using the shared key between Alice and Bob receives the message. Now Bob is able to decrypt the message using the key K. But since Alice also has stored the key, when an attacker is able to get the key from Alice, to steal the key from Alice, he or she can then decrypt the message also. So we have 2 points where we can steal the key with symmetric encryption algorithms. Now let's have a look at a reminder of asymmetric encryption. And as you also probably know from our previous videos, asymmetric ciphers, for instance, use 2 different keys. That's why we call them asymmetric, for encryption and decryption. For instance, with RSA, we have a public key E that is known by everyone, and that is public knowledge. So everyone can encrypt a message for us using our public key. And then we have a private key that only the owner of the key pair E and D has. Only I have my private key. So when you encrypt messages for me, I'm the only one able to decrypt that message. Only known and used by the owner, that private key D. And this key, of course, has to be secret, that has to be kept secret, and only the intended or the owner of the key is allowed or should know that key. We have also some advantages and disadvantages. The advantage at first is that only the owner of the private key is able to decrypt the message. So even the one who encrypted the message can't decrypt a message anymore. So when we encrypt a message and someone is able to attack our computer, he or she cannot decipher messages that we created for others using their public keys. This is really good. But there are, of course, some disadvantages, or at least one disadvantage. And the biggest disadvantage of asymmetric encryption is that it is very slow compared to symmetric encryption. And for this video, I did a performance measurement with CryptoTool, and I used the RSA and the AES component, and I measured their execution times. Be aware that this is only true, or these measurements is only true or only valid for CryptoTool. For instance, TLS or SSL could have different times, but I did this measurement only to show you the magnitude of difference between symmetric and asymmetric encryption. So what did I do? I encrypted 1 megabyte or megabyte of data, and I encrypted this data using RSA with 2048-bit, and I encrypted the same data with AES 256-bit in cipher blockchaining mode. And here you have the difference. RSA with CryptoTool, I measured the execution time of the RSA component, took 2 to 4 seconds. I did this, of course, several times, and it took 2 to 4 seconds to encrypt the message, the 1 megabyte data. AES only took 60 to 100 milliseconds to encrypt the same data. So in CryptoTool, AES is between 32 and 66 times faster than RSA. So when you have to encrypt hugest amount of data, then you of course should use AES for that and not RSA. Now let's see what is hybrid encryption. And hybrid encryption combines the advantages of symmetric and asymmetric encryption. Let's have a look at an example for that. Alice wants to send an encrypted message M to Bob using hybrid encryption. And we have a simple protocol to do so. At first, Alice generates a random symmetric key K. Then Alice encrypts the message M for Bob using a symmetric cipher, for instance AES, with key K, the generated key. After that, Alice encrypts the generated key K with Bob's public key eBob. At this point, only Bob is able to decrypt the key K with his private key. Then Alice sends the encrypted key K dash and the encrypted message C to Bob. Bob then decrypts the encrypted key K dash using his private key dbob. And as we said, only he is able to do so. And he gets the key K. Finally, Bob decrypts the message C using the symmetric cipher, for instance AES, with key K. And for the asymmetric ciphers, of course, here Bob and Alice use, for instance, RSA. And in the end, Bob decrypted the message Alice sent to him. We have a lot of advantages using hybrid encryption. At first, only the encryption and decryption of the symmetric key K and K dash is slow. And therefore, we only encrypt the used key, or what we call session key, using, for instance, RSA, which is slow. Then the encryption and decryption of C and M, so of our ciphertext and our message, is very fast. For instance, using AES as our symmetric cipher. And we speak of you encrypt the bulk data in that case using, for instance, AES. And another advantage is that only Bob is able to decrypt the message, since only Bob can decrypt the encrypted key using his private key. So even that we used a symmetric cipher, only Bob is able to decrypt it, because he has only his private key and can decrypt the encrypted key. And even Alice is not able to decrypt the message if she lost K. So of course, when Alice still has the original key, she can decrypt the message. But in our protocol, Alice would throw away the K, and then even if an attacker can get access to her computer, he cannot decrypt messages that she created for Bob. And we have many examples where hybrid encryption is used, and many famous examples. For instance, network protocols. For instance, IPsec and TLS SSL use hybrid encryption. And of course, secure email, and in that case PGP and SMIME, also use hybrid encryption. Only the keys for the symmetric ciphers are encrypted using the asymmetric ciphers, which is slow, and the actual N and decryption of the messages is performed using a symmetric cipher, which is very fast. And now, as I promised in the introduction of that video, we will have a look at hybrid encryption in CryptoTool. We will create our own hybrid encryption scheme and play a little with that. So let's go to CrypTool 2. I'm here now in the Start Center of CrypTool 2 and I want to create my own hybrid encryption scheme. And I thought it would be interesting to create a complete new workspace with hybrid encryption. So let's do it. At first, I start a new instance of the workspace manager. Then we need Alice and Bob. And to know where Alice and Bob are, I think we just use these labels here. So we have the Alice side and we will have the Bob side. And we want to send messages from Alice to Bob. To do so, we need an RSA pair for Bob. So we have to create, using the RSA key generator, a key for Bob. And for this example, we will use small keys. So I set this to, no, not enter randomly. We want to manually, we want to generate random primes. And for our case, I think 256-bit. No, let's use 512-bit. In the real world, you would use at minimum 2048 or maybe even more 4000-bit keys. But this takes some time to generate these keys. So as a demonstration, we use 512-bit keys. And this here is key generation, RSA key generation Bob. Then we need a message. So we create our message. And this is the message M. And Alice wants to send to Bob, hello Bob, how are you? And then on the receiver side, we want to, of course, see the received message. So this here will be the decrypted message M. And now we need to create a key for our session, for our transmission here, for our simulated transmission. And for that, I use a random number generator. So this here will be our key K. And since I want to use AES with 256 bits, we need 32 bytes. And I want to use a random crypto service provider in that random number generator. Then we need AES. And I will first create our transmission here without the RSA. So we will have an AES here. We need some converters, so we need a string encode, we need a string decoder. Since the AES wants a byte array, we have to convert our text here on the Alice side to bytes. And then we need the stream here. Then we need another AES for decryption. That will be on the Bob side. And then we have to encode the received data since it's still a byte array here. And we want to show that here. And to make it a little nicer, we can align this on top. So our message will be encoded or converted to a CrypTool stream. Then the CrypTool stream will be encrypted by the AES. So we have to change this AES to encrypt 256-bit. Padding mode is PKCS7. We have to do the same on the receiver side, but with decrypt. So decrypt 256-bit, PKCS7, and we want to have cipher block chaining and cipher block chaining. And now our randomly generated key can just be provided or given to the AES. And to make it easy in that case, I will not give an initialization vector to AES. In the real protocols, you would also send the init vector or not encrypted, but in our case, I will just omit this to make it easier. Now let's have a look. And as we can see, our symmetric cipher works very well. We generate each time we send the message using the generator here a new key. Let's just have a look at that. So we can have a debug output here. So when we restart the workspace, this here is our key K. We have every time we restart it a newly generated key for the AES. But of course, we have to provide this key to Bob, since Bob has to decrypt it. We could assume that Alice and Bob know the key, each know the key, but as I said, or as part of, or as topic of this video, we want to create a hybrid encryption scheme here. And to do so, we have to encrypt using the RSA. And here we have the N, then we have the private key D, and the public key E. And then we can use the RSA component here on both sides. So we remove our key here, not in that case. So Alice, of course, uses that key here for encryption using the AES. But here, in that case, we want to send the encrypted key to Bob. So here we have RSA and we say encryption. We need the N. The N is public knowledge. Then we need the public key from Bob. That is, I think, this here. No, this is a message. When we use numbers, we have to put the public key here, private or public key. And this is encryption. This is still, so here you can draw a line still on Alice's side. On Bob's side, we also need an RSA. Alice would send our encrypted ciphertext here. And this is the encrypted key, K dash. So I will put this here below, K dash. To Bob. So we have a debug output. And this also goes to the other RSA of Bob. Then we need the private key from Bob. That goes into this input here, private public key. And we need the N from the RSA. And then the correct key here, that will be again the key K. So I will put a debug output here. This is K. This is K star, K dash. This key will go to the AES. And now, instead of sending the key directly to Bob, we send the encrypted key K dash to Bob. Bob then decrypts the key K dash, and it should work. Let's start it. Now let's have a look. Okay. Of course, we should change on the receiver side to decryption. And now, as you can see, we have here our key K that Alice generates on the sender side. Then we have a very huge K dash. This is the RSA encrypted key. This is then sent to the receiver side, to Bob. Bob uses here his private key to decrypt the key that Alice generated, uses this decrypted key with the AES. He's able to decrypt the key, the message that he received from Alice, and finally gets the message back. And with this scheme, every time we restart this, we will get new keys, since our session key that they use here for the symmetric cipher is always newly generated. And this is how hybrid encryption works. And of course, we could, let's just also create an init vector. So the init vector, Alice would also create. I hope you can see, I will create that init vector here. So for AES, we need an init vector of 16 bytes. We will put it here into the AES. The init vector is used for the encryption. And then Alice would just send the init vector unencrypted to Bob. This should also work. And let's just put a debug text output here so that we have an IV. connect the random number generator for the IV here, and let's just press play. And now we have no warnings, or we hadn't warnings, we had info boxes or info messages at the AES that we do not provide an IV, an initialization vector. Now we generate one, now the AES is happy. And now every time we generate, we send a new message, or send the message again, we get a new IV, we get a new session key, and of course new encrypted K dash. Now, just for fun, let's change this to RSA 2048-bit. Then you see that this takes some time. So Alice has to wait for the public key for Bob. And Bob also, of course, needs a private key. Now we have a 2048-bit RSA key pair here. Here you see a warning, since CryptoTool gives us a warning when it takes some time to generate these keys. And now it works with RSA 2048-bit. Yeah, in this way, or in using these components, we can create a hybrid encryption simulation in CryptoTool. And I think this is everything I wanted to show you in this short video. You learned what is hybrid encryption, what are the advantages. The main advantage is that we use the power of asymmetric encryption to encrypt the symmetric cipher key, the session key, and then that we then use the power of symmetric ciphers to encrypt very fast the messages. And the receiver side, then only the key has to be decrypted, which is slow, and all the following bulk data can be decrypted using, for instance, AES. And as I said, this is everything I wanted to show you in this short video. I hope you like it. If yes, please give a thumbs up. Also, if you did not yet subscribe to this channel, I would also be really happy if you do so. If you're interested in cryptology and want to see more videos like that, then please do this. This really helps me to grow this channel and also to make CryptoTool more popular. So thank you very much for watching, and see you in the next video.